everyone. Today we are going to discuss a very important concept, that is graphing exponential functions. So first of all, I will give you the overview of the exponential function. Then we will see that how we can graph the exponential function and some important details that we can extract from the exponential function without graphing it as well. So let's start with the general form of the exponential function so that you can have the clear concept about it. So the general form of exponential function is f of x is equals to a dot b raised to power x. This is the general form of an exponential function. Now let's see what these all these terms mean in this function. So f of x basically, you know that it's an output or the y. A plays a very important role in the exponential function, as it represents y-intercept or scaling factor of the exponential function. Either the exponential function will stretch or compress. It depends on the value of this a. So it is either a scaling factor, or you can say y-intercept, or you can say this is the point where the graph will cut the y-axis, or you can say where x is equals to 0. Then what is b? B is basically the base of an exponential function, and it depends on the value of b that whether the function will grow or it will decay. So I'll tell you, or I will explain the importance of this b in a little bit later, but currently you just know it is basically a base that will decide whether the exponential function is growing or decreasing. Lastly, we have this x. This x is basically the exponent. That is, you can say the value of exponent, that is the value of x on the graph, just like the value of y on the graph. So this is the general form of an exponential function. If I write here, this is general form. So we will move towards some specific exponential functions so that you can have the clear concept that how you can graph the exponential function and how you can extract important information from any exponential function given. So here I have written two different exponential functions. One is f of x is equals to 2 raised to power x, and the other is f of x is equals to 0.5 raised to power x. Now comparing these two functions with the general form of the exponential function, we have to extract some important information before graphing it, so that whenever you will be asked some question regarding the exponential function graphs, you should know without plotting the graph. I will also tell you the plot at the end, but first you should know some basic information that you can easily extract from the equation only. So while comparing these equations with the general form, it is easier to say here that this 2 is representing the base b. So what is the purpose of this base? If I write here, if the value of b is greater than 1, it means that the exponential function is growing. Now what does it mean? I will explain it by drawing as well. But currently you should know that on the basis of the value of b, you can know in advance without plotting the graph that the function is growing, it is increasing in certain direction. So similarly, if the value of b is greater than 0 and less than 1, like as in the case of second example, that is f of x is equals to 0.5 raised to power x, here it is clear that this is the value of b and it's less than 1. In such a case, the exponential graph, or you can say the graph of the exponential function will be decaying. Decaying means it will go down. I will also plot it, that then you will understand what does it mean with growing and decaying. So on the basis of just the equation, we can understand these values. Other than this, we have another information here. What is a? Here a is equals to 1. That represents y-intercept. It means the graph of this exponential function will cut the y-axis at y is equals to 1. While in the second case, if I write here the case 1, this is case 1, this is case 2. While in the case 2, here again we have a is equals to 1. As it is 0.5 is multiplying with 1, there is no scaling factor other than that, so we will consider it 1. So as a is equals to 1, again here the y-intercept is 1. That is, the graph of this exponential function will also cut the y-axis at 1. So this is the information that you can extract from the given functions without plotting them. Now let's plot them together. So we have to plot this given exponential function from the equation given, that is f of x is equals to 2 raised to power x, or you can also write it as y is equals to 2 raised to power x. So you just need to take the random values of x and put this in this equation of y is equal to 2 raised to power x to get the value of y. So I'll start with the minus 2. On minus 2, so if we put the value of minus 2 in the given function y is equal to 2 raised to power x, we will get 0.25. If we put the value of minus 1, we will get 0.5. Then 0, it will be 1. Then on 1, it will be 2. And for 2, it will be 4. For 3, it will be 8. And for 4, it will be 16. So these are the just values for plotting the graph. Same is in case of the case 2, 0.5x. We will take values minus 2, minus 1, 0, 1, 2, 3, 4. These are just random. You can take any other value. So if we put the values of these x in the function, that is f of x, y, we replace f of x with y is equals to 0.5 raised to power x. So we need to put the values of x here to get the values of y. So it will be, for minus 2 it will be 4, for minus 1 it will be 2, then for 1, 0.5 will be 0.25, it will be 0.125, and it will be 0.0625. So it is decreasing. So these are the values, and let's see how the graph of these values will look alike. So let's plot these points as, if I start from minus 2 and 0.25, it will be very close to the x-axis, like somewhere here. Then we have minus 1 and 0.5, it will be a bit above the x-axis. Then it will be 0, 1, that is on the y-axis. This is basically the y-intercept that we have seen, a is equals to 1. Then on 1 and 2, then this point where 1 is the x-axis and 2 is the y value. Then we have 2 and 4, this will be the point. Then we have 3 and 8, and it's somewhere here. So if I join these values, you'll see that it is like that. So if I just extend it, it will be like this. So it is clear here that the graph of this exponential function is growing. It is growing. So it is clear here that we have evaluated without drawing the graph correctly, that the graph of this exponential function will be growing. Similarly, in the second case, if we draw the points, we'll see x is minus 2 and the y is 4. This will be the point. Then minus 1 is the x and 2 is the y. This will be the point. Then 0, 1 is the y-intercept, that is where the graph will cut the y-axis. Then on 1, we will have 0.5 for the y-axis, this point, and then for 2 is this, for 3 is this. So if we join these points, what we will get is like this. So it is clear here that the graph is decreasing. It is decaying. So we have find it correctly in the start that the graph of this exponential function will be decaying, because the value of b was between 0 and 1. So it all depends on the value of b, that whether your graph is increasing or decreasing. So this is how you can tell without graphing or without plotting the exponential function, that whether the graph of this exponential will be increasing or decreasing, and what will be the y-intercept of that graph. So it is clear here in both the cases, the y-intercept, that is the point where the graph is cutting the y-axis, is 1 in both the cases. So this point is showing the y-intercept. So another important thing that related to the exponential function is, by looking at this, I can say that when you can say the domain and range, very important concept that you need to mention here, that what will be the domain and range of the of these exponential function. So here it is clear that in the graph where the exponential function is growing, we have, as the x is approaching the infinity, it is clear here that this red line is going to infinity, it is not stopping anywhere. It means the y is also approaching the infinity. So we don't have any end point of x and y. So it means, so it was on the positive side. But when we see towards the negative side, that as x is approaching towards the negative infinity, that is the negative infinity, then as x is approaching to the negative infinity, y is approaching to 0. Or you can say that y is never equal to 0 here. Just keep in your mind, but it is approaching to 0. So whenever we mention the domain and range, we consider it as 0. So the domain of this exponential function will be, domain basically refers to the input or the value of x. It means any value of x will be possible, or any value of input is possible for this given function. And the range is the, in turn, what will be the value of y if we put minus infinity to plus infinity in the given function. So it is shown here that it is clear from the graph as well that we are not getting any negative values of y, as negative values of y are here. So as graph is not approaching there, so we can say that the range is approaching from 0 to infinity. So this is the domain and range of this function. Now let's see the domain and range of the other function. Here again, it is clear here that as we are moving towards x towards positive infinity, this is the positive infinity, it is clear here y is approaching to 0 as it is decaying. But when we are moving to negative infinity, this is negative infinity, where the y is going? Y is also going to the infinity, that is positive. So the domain and range of this will be, if I write here, what will be the domain? That is the value of x. It is clear here from here that it will be minus infinity to plus infinity, and the range will be, that is the value of y will be 0 to plus infinity. It is clear here again that there is no value of y that is in negative included in it. So that's why its range is 0 to positive infinity. While for x we have positive as well as negative values, that's why its domain is from minus infinity to plus infinity. So that's all from today's lecture. Thank you.